Welcome to Power University, where today we're going to go over the SolarEdge Home Hub Ecosystem tips and tricks. So the most important part of a SolarEdge Home Hub installation is getting the consumption CTs installed correctly. So consumption CTs always need to be on the line side of all home loads, solar and batteries for battery backup installations. The SolarEdge CTs need to face the grid or away from the customer's home. The black and white wires from the CTs need to be landed in the correct ports. You'll see a little sketch here with white, black for the consumption CTs. Switching the white and black wires is the same as pointing the CTs in the wrong direction. That would be reversed polarity. So the backup interface, starting in EUSGN, has consumption CTs built in. Now this is for a 200 amp whole home backup system only. If that MID is used in any other situation other than a whole home backup, then you have to pull out or unterminate those factory installed CT wires, cap them off with a wire nut, and install an external set of CTs on the line side of all home loads, solar, and batteries. Now in any other situation, you're going to use that BINUSGN, which does not have built-in consumption CTs. Again, you just install that external set. With the SolarEdge Home Hub ecosystem, there's two major differences in this system, and that is whether the battery is providing backup power or whether it's just used for arbitrage. So in an instance where you have a backup interface installed that is for backup, you're going to terminate the consumption CTs in the backup interface meter in the bottom right hand corner of the backup interface. You're going to, and just remember, the backup interface meter is meter 2. The energy meters in any of the solar inverters are meter 1. So in this case, you're going to program meter 2 or Modbus ID 2 to import, export. You also always need to make sure that the CT rating is 225 amps. Those slim clamp-on SolarEdge CTs are 225 amp CTs. If you make any other choice there, commonly people choose 200, it's going to make the readings incorrect. And then for meter 1 or the solar inverter energy meter, we're going to set that meter 1 or Modbus ID 1 to inverter production. Again, because the built-in production CTs are factory installed into that energy meter and the inverter. So again, you're going to pull inverter production from the energy meter and the inverters. You're going to be pulling the consumption data from the backup interface. So for these non-backup battery systems, you have no backup interface. So all the CTs are going to get terminated into that energy meter inside the inverter. And you're going to set meter 1 or Modbus ID 1 to inverter production plus E/I. And again, make sure you set those CT ratings for the consumption CTs to 225 amps. I believe in the built-in production CT is a 50 amp CT. The next most common reason for CT failures is phase alignment. So essentially, what we need to do is we need to make sure the CT that is terminated into the L1 CT port in the energy meter is on the same phase or the same wire essentially down the line as the wire that's terminated in the L1 lug in the backup interface. Now that also has to be on the same phase as the wire terminated in the L1 port on the solar inverter. So again, you just have to use colored wire. Do not waste your time running black wires. Keep track of your L1 and your L2 all the way through the system. Carefully make sure you don't cross L1 and L2 anywhere. And then test with a voltmeter at the end of every installation to make sure you didn't go wrong somewhere. Again, to test phase alignment, we're going to want to make sure we keep the L1 and the L2s consistent through the entire system, that at no point do we cross L1 and L2. So not only can you do that by carefully color coding the wires and tracing them all the way, once you're done, you can verify with a voltmeter. So first, what you do is you turn the voltmeter to volts, alternating current. From there, you take one probe, you find where the L1 CT coming out of the energy meter is. You trace that and you figure out, right, it doesn't matter if it's black or red or pink, right? It just matters which wire is the CT terminated into the L1 port of the energy meter. In this case, it's the pink CT. So we're going to check that lug, and then we're going to put our other end of our voltmeter on the L1 lug in the backup interface. We want to see 0 volts. We're then also going to make sure that, say, if we had a backfed breaker connection, we didn't swap phases there, right? So we put it on the black wire leaving the breaker to the L1 lug. Again, 0 volts. We want to see 0 volts. That means we are on the same phase. We check between the L1 lug incoming in the backup interface to the L1 lug on the circuit breaker feeding the inverter, 0 volts. Lastly, we check that to the L1 lug going into the solar inverter. We want to see 0 volts. If at any point we get 240 volts, you have crossed phases somewhere and you need to fix it. Now, another common issue that you're going to see is when you do this, right, maybe you can't reach. You know, these voltmeters aren't very long. It's about an arm's length. Maybe the main service panel and the backup interface are 20 feet apart. Well, you know what? There's no problem there, because what you can do, so this is obviously for demonstration purposes only. This wire could be 1 foot or it could be 30 feet. But essentially, to extend this voltmeter, you're going to take your wire, you're going to take your voltmeter, you're going to take both ends, you're going to wrap it up in a wire nut. You make sure it's nice and secure. Then you wrap a zip tie, I don't have one on me, around it and tighten it down really hard to make sure they're not going to separate. And then you wrap it up in electrical tape to make sure you've got a nice solid connection. This is not going to come apart while you're testing high voltage electricity. Now, always use your own company's safety protocols. This is for educational purposes only. But now, in this case, right, you could reach, you could have someone on the inside of a customer's home 30 feet away with one end and someone else at the other end with the voltmeter, testing equipment that's quite a far distance apart. Okay, lastly, this is how you test phase alignment when you're by yourself or in a situation where you can't reach both pieces of equipment. What you can do, let's pretend this is the main service panel, and we've got our L1 CT on this black conductor. Well, we could take that wire end of the voltmeter extension, land it in a single pole breaker. We take that breaker, we follow that L1 conductor down, we find the first open stab on that L1 bus bar, and we turn this breaker to the off position. Again, you would want to do this while the panel is de-energized. You would snap the breaker into the L1 lug. You would turn the breaker on. You would energize the panel. You would turn your voltmeter to volts alternating current. And then, you know, if you're on the same lug, you get 0 volts. See that? If you're on the opposite lug, you'll get 240. Now let's just pretend this right here, the sub-feed lug kit, is feeding our backup interface, right? Black wire, L1 CT. This is L1 feeding the backup interface. Uh-oh, we've got 240 volts. That would mean someone did not pay attention when they color-coded these two wires. The red wire is actually on the same phase as the black wire up here. So, assuming we want to just keep black as L1, we would want to swap these wires to make sure that our phases are aligned. Beware of Eaton CSR breakers. These are commonly used in many other manufacturers' equipment. For SolarEdge, you don't really have to worry about it unless they're installed in a main service panel somewhere. And so those cross phases inside the breaker. So L1 on one side of the breaker is going to be the opposite on the opposite side of the breaker. So you can really get swished around there if you don't test with a voltmeter. Next, very common failure point here are the high power inverters. So the high power SolarEdge energy hubs, that is going to be the 3800 watt and the 7600 watt inverter. These inverters have a higher output off-grid than they do on-grid. And the reason for that is so you can still say if you have a 200 amp service with a 200 amp main breaker, you only have 32 amps of backfeed that you can connect to that service. You can connect this 7600 watt high power inverter. The backfeed to the main service panel while it's on grid is always going to be 32 amps. But the moment it goes off grid and the backup interface disconnects the inverter from the main service panel, it can send up to 43 amps continuous from the solar inverter through the backup interface to the backed up loads panel. And for that reason, those breakers inside the backup interface have to be sized appropriately for that off-grid current. So for the 7600, that is going to be a 63 amp breaker in the backup interface. And for the 3800, that's going to be a 40 amp breaker in the backup interface. And those are a very specific type of breaker that you will need to pre-order in advance of the installation. The next most common reason that you are going to get rework requests from our department or get finance rejections for a SolarEdge Home Hub Ecosystem install is no online data. SolarEdge systems need to run for sometimes 4, 5, 6, 7, 8 hours before they're going to populate online data. That is especially specific when you're using a cellular connection, which is required on every TPO or third-party owned system like Sonova, Everbright, or others. So in that case, we recommend just leave the system running at the end of the day. If you are in a location where you can't do that or you don't feel comfortable doing that, we recommend using standby mode. So that's going to allow you to leave the inverter and the backup interface connected to AC power. It's going to continue to communicate to the web, but you're basically just disabling the inverter production and battery production. And so if you leave it in standby mode overnight, it should upload that data to the web as long as you have let the system run, as long as possible on site. If you ever extend the CTs, you're going to want to use twisted, shielded, 600 volt rated CT extension wire. Every crew should have a roll of this on their vans for extending CTs. You never want to rig up CT extension wires from anything else. It's just going to cause you more problems and headache in the long run. So the twisted and shielded is to prevent electromagnetic interference, which will scramble the CT readings. 600 volt rated is more of a code issue. With SolarEdge, you're talking high voltage DC. If you have communications wires in that same compartment, they're required by code to be the same voltage as the system. Lastly, site capture. We need site capture filled out completely. Every single section. Please have your techs use it on site. Read through every single section carefully, especially in regards to CTs. We need all CTs documented. We need to see the CT arrows. We need to see the CT terminations. We need very close-up photos of the CT splices if you're splicing CTs, and we need those commissioning screenshots showing that the meters are set up correctly and the CT ratings are set up correctly. Okay, lastly, once you have online data to look at, there's a few things to really just look at these graphs to understand if the CTs are installed correctly or not. So right here is an example of accurate consumption and production monitoring with backup only. You'll see consumption just kind of bounces around under the line there. It doesn't change when the sun comes up or goes down. It just starts taking consumption from the solar rather than from the grid. Again, same thing, but this is in maximized self-consumption. So consumption's just bouncing around from the grid at night. Once the solar comes up, it's pulling from the solar, a little bit from the batteries. Once you're at the end of the day, it starts pulling from the batteries. But you'll see consumption again is just kind of doing its own thing, has no correlation to solar production. So this right here is a clear sign of a CT error. In most cases, this is phase alignment when you have the CTs on the wrong phases. You have no consumption whatsoever until the sun comes up, and when it comes up, consumption is double production, or this is one form of what we call mirroring. So again, you should have some amount of consumption at night, and you should never have consumption mirroring production. And then lastly, this one's not as noticeable, but you'll see consumption looks normal. It's bouncing around at night from the grid. But then you'll see when the sun comes up, consumption spikes with solar production. When the solar production drops, the consumption drops. When the solar production rises again, the consumption rises again. And then once the solar goes down, it's kind of doing its own thing again, right? This is a clear sign of a CT installation error because consumption in the home and solar production have nothing to do with each other. There should never be any correlation between those two values. Well, thanks for watching. We'll see you in the next one. So we now have a pretty important update to the SolarEdge high power home hub inverters for the US domestic content. As we all know, this is the way the industry is moving. Many of our TPO providers require domestic content now. The big thing here is the SolarEdge Home Hub Inverter Domestic. They all, regardless of the model, whether it's a 38 all the way up to an 11.4, the output in backup operation is 11,400 watts or 48 amps continuous. What this means is regardless of the size of the Energy Hub inverter, if it is a domestic inverter, you must size the wire between the inverter and the backup interface to number 6, and the breaker in the backup interface must be 63 amps. Again, the reason there is even if that 3800 watt inverter only has 16 amps when connected to the grid, as soon as it goes off grid and it discharges through the backup interface to the critical loads panel, it can discharge up to 48 amps continuous. And so that'll require number 6 and a 63 amp breaker. Rather than trying to change your design guidelines between if it's a domestic inverter or a foreign inverter, in my opinion, it's not that much more cost. The easiest thing to do would just be to go 63 amps and number 6 across the board for any SolarEdge backup configurations. And that way you just always know when the system goes into backup mode, no matter which inverter you have, you're not going to end up having that breaker trip causing a power outage on the homeowner during their outage and resulting in a service call. Thanks so much for watching.